Hello and welcome to Learning Rust Programming tutorial by me, that is Ashish. Today we will learn about one of the important feature of Rust, that is fearless concurrency. But first, we should revise what is concurrent programming and parallel programming. Concurrent programming is where different parts of a program execute independently, whereas parallel programming is where different parts of a program execute at the same time. So it's independently and at the same time, two very important keywords. Handling concurrent programming and parallel programming safely and efficiently is another of Rust's major goal. Historically, programming in this context has been very difficult and error prone, and Rust hopes to change that. Rust team often use the term fearless concurrency. So what exactly is fearless concurrency? So let's look at it. So Rust team believes that the ownership and type system that we have learned in our previous videos are powerful set of tools to help and manage memory safely and concurrency problems. By leveraging ownership and type checking, many concurrency errors are compile time errors in Rust rather than runtime errors. Therefore, rather than making you spend a lot of time trying to reproduce the exact circumstances under which a runtime concurrency bug occurs, incorrect code will refuse to compile and present an error explaining the problem. As a result, you can fix your code while you are working on it rather than potentially after it has been shipped to a production. Rust team have nicknamed this aspect of Rust as fearless concurrency. So Rust compiler is going to get you a lot of trouble during development, but once your app is shipped to the production, then you can live peacefully. So let's create our first multi-threaded program in Rust. So Rust standard library uses a one-on-one model of thread implementation. So if you have seen our Java multi-threading video where we have seen virtual threads and platform thread. So here we are talking about platform thread like architecture where programming language creates one-to-one thread to a system thread. So program uses one operating system thread per one language thread. That is the model. So there are crates that implement other models of threading that make different trade-offs to a one-on-one model. So that we will check, that we'll talk in later videos. But today we'll be talking about this one-on-one model that comes in standard library. So to create a thread, we import, let's start. We import standard thread library. So to create thread, we call thread.spawn method, and inside that we pass lambda. So this lambda is the task that will be performed in a background thread. So here if I do print ln some task, and if I want to add sleep, then what I can do is I can do sleep, but for that I need to give duration, and that duration we have to use standard library duration, and from duration I can have from milliseconds. I can say I want to sleep for 1 millisecond, and after that suppose, so this will create a single thread. Now if I want to create 5 threads, what I'm going to do is create a loop. Okay, so this loop will run for 5 times and will create thread, and what we are going to do is we are going to sleep this main thread for some time. All right, so let's run this code. So here you can see some task has been printed 5 times. So if I want to print the name or ID of the thread, then what I need to do is yeah. So here you can see thread ID 24536. So this is how you can create thread using thread.spawn method, and you can use sleep. Now if I have vector, and if I try to access that one here, And if I drop that vector here, and if I run this, so you can see there are errors. So closure may outlive the current function, but it borrows v. So this was we were talking about. So due to this ownership and type checking, at compile time itself, we come to know that this v, we cannot access this v. This is not the right way to access this vector. So this is about simple threading program. We'll talk about more threading in our next video. We'll talk about how to share data between the threads and much more. So that's it from this video. Thanks for watching my video.